All right, so geometry, we're going to talk about some probability and statistics topics for the rest of the school year. So today's probably the longest day in terms of the notes, but it's not the most difficult. So be aware of that. And some of this stuff you might already know. So when we're finding probability, again, the probability of any outcome of a chance process is a number between 0 and 1 that describes the proportion of times the outcome would occur in a very large number of repetitions. So again, when we say between 0 and 1, typically probabilities can be decimals. So 0 and 1. They can be percents. So if they're percents, then they're going to be between 0 and 100%. Or they can be fractions. Okay. So three different ways to represent a probability. So when you're talking about the probability of an event is any collection of outcomes in a chance process, right? So if I have a deck of cards, an event could be getting a heart, right, or getting a spade. If I have a die, 1 through 6, probability of really an even number, something like that. So when you find a probability, so this A is the event, you're looking for the number of times that event that you want to happen can occur out of the total, right? It's what you want out of the total. Okay. So be aware of that. And again, this should be old news to you. So sample spaces. Sample spaces are all possible outcomes. All possible outcomes. So example, when I roll a pair of dice, right? So in the first column here, the blue die is remaining a 1, but then the red die is turning into a 1, 2, 3, 4, 5, 6. So these are 6 outcomes, all with the blue die being a 1. And then what if the blue die is rolled a 2? Then again, the red can be 1 through 6, and so on, till we get all outcomes. Now, if you want to figure out the total number of outcomes, there's kind of a trick you can do. So if I'm rolling a pair of dice, that means there are 2 dice. So look what I'm going to do. I'm going to put a bar, a time symbol, and another bar, right? So how many total numbers can that first die be? Well, that first die could be one of 6 numbers. How many total numbers could that second die be? It could be 6 numbers. This multiplication problem will give you the total number of outcomes, 36. And if you look, there are 36 pairs of rolls. So that's a cheap way, or a cheap way, not cheap way, a shortcut way to figure out how many total outcomes there might be. Okay, so we're going to be dealing a lot with two-way tables and Venn diagrams. So when you have two-way tables, this is where you have each individual or whatever thing you're looking at, each has 2 characteristics. So in this two-way table, our first characteristic is gender, male or female, and then the second characteristic is, do they have a pierced ear, yes or no? Again, we call these categorical variables because they put you in a category, male or female, pierced ear or not pierced ear. So notice here in this two-way table, this bottom 178, this is the grand total. So there were 178 people that were looked at in this survey sample. So in this two-way table, every row equals its total, even down here, and every column equals its total, even here. So keep that in mind as you are looking at this. And again, each of these boxes in here represents someone who has 2 characteristics. So these are 19 males with pierced ears. Okay. Now, a Venn diagram is another way to visually show individuals with 2 sets of data. So we use what's called a Venn diagram and 2 overlapping circles to show the sample. So let's say event A is being male, and let's say event B is having a pierced ear, so saying yes. So what I would do first is I would first fill in the overlapped region. So there are 19 males with pierced ears. Now, this yellow circle represents all of the males. Well, if 19 of them have pierced ears, then how many males don't have pierced ears? 71. The 71 would go there. This circle here represents all of those with pierced ears. Well, if there's 19 males with pierced ears, how many females have pierced ears? That'd be the 84. 84. So this yellow circle should add to 90, which is the total number of males because it's the male circle. And this blue circle adds to 103, which is the total number of pierced ears. So then inside this rectangle, which represents the entire sample space, there's going to be a number that goes here in this corner. And that's going to be all of the non-males and non-pierced ears. That's this box right here, 4. Okay, so these are not males and they don't have pierced ears. There's only one box on the table there. So if we add these numbers together, 71 plus 19 plus 84 plus 4, that's going to be 90, 174, that's 178, and boom, that's the grand total. So whenever you fill out a Venn diagram based off two-way data, that the sum of these 4 numbers should be that grand total. Now, there's names for these certain things. So the overlap is called the intersection. This is where A and B both occur. It consists of all outcomes that are common for both. So the symbol for and is this upside down U. You might see that. It's called the intersection. Typically, it's a small amount, small probability, as you can see there. Okay, the union, or A or B, consists of A or B or both. A or B or both. So it's all of that, okay? Now, there is this general rule. It's an addition rule for 2 events. So if you're calculating the probability of A or B, you take the probability of A, which would be this circle. You would add the probability of B, which would be this circle. But the problem is that this overlapped region, you count twice because you count it in the A circle and you count it in the B circle. And remember that overlapped region is the A and B region. So that's why you do this part. You have to then subtract the probability of A and B one time so that you don't count that middle section twice. Okay, so be aware of that. Now, sometimes 2 events don't have a middle section. They don't have an intersection. Those are called mutually exclusive events. 2 events that have no outcomes in common. That is where the probability of A and B occurring is 0. Notice here in the Venn diagram, they're completely separate circles. So now, when the general rule had this idea, minus the probability of A and B, because it equals 0, you don't need that. And for mutually exclusive, you just add A and B's probability together because they have no outcomes that are the same. And then I think last but not least, the complement rule. So when you think of complement, I know we talked about complementary in this class, not that. Complement, when you think of the word not, right? So the complement rule for a complement, the probability of A complement is equal to 1 minus the probability of A, where A complement is the complement of an event. That is the event that A does not happen. So a complement can be thought of as not A. So this is like saying not A. So what's the probability of not A? Well, you take everything, 1 is everything, minus the probability of A. Here's your Venn diagram. If A is inside the circle and the square rectangle represents everything, then everything outside the circle is not A. Okay, so A, not A. Okay, so like I said, a little bit longer notes here. So I'm going to stop the video, and then I'm going to go into Delta Math and do a couple problems with you on a second video.